Hi, in this lecture we will see what variables in Python are, how to create variables, and internally how the values of variables are stored, how the memory is managed in Python programming language for any type of variables. So let's start. Firstly, what is a variable? A variable is a name that refers to a value stored in memory. So if I write x equal to 10, then 10 is stored in memory somewhere, in binary obviously. So let us say 10 is stored somewhere in memory, like it has, every memory location will have an address. Let us say the address is, address number is, let's say 1237, the address number is this. Then when I say x is equal to 10, x is just the name that is pointing to this memory location. X is just a name, that name of the variable that is pointing to this memory location. Okay, so variable is a name that refers to a value stored in memory. So if I write x equal to 10, or let's say if I write name is equal to Alice, so Alice as a string will be stored in memory like this. The characters will be stored ALICE, and then there is a character which is present at the end of every string. So just the compiler can know the string ended here. Okay. So Alice will be present, or forget about this particular thing right now. We will see this in strings. For now, let us assume that only Alice is present. The string Alice is present in memory. And let us say it is present in memory location 3724. And I say name is equal to Alice. Then the name here is just the name of the variable. And that is pointing to this memory location. Okay. So when I say print x, let's say when I say print x, now for our convenience, we know the variable, the name of the variable is x. Now the compiler will try to decode where x is present, and then the value of x will be printed on the screen. Similarly, if I say print name, for our so the name of the variable is for our reference, and compiler also knows, so that the programming becomes easier. That is why Python is called a high-level programming language, right? So that we can manage variable names, because see, for a human, it's easier to remember human readable names and then access those particular memory location via names. We cannot work with these memory locations directly. It will be very difficult for us. So that is why we just try to name these memory locations, and then now the compiler also knows all these names, and it can refer to that particular memory location and extract whatever is there. Okay. So this is what a variable is. Python variables are just references. References means address. Here x is the name of the variable, and it refers to this memory location. X is a name that refers to this memory location, and hence this particular thing is called a reference. So Python variables are just references or pointers to objects in memory. Okay. Now in Python you can assign variables just like this, x equal to 10. And you can actually assign multiple values to multiple variables at once also. So multiple assignment is possible in Python. It is generally not allowed in many programming languages. C, C++, Java doesn't have multiple assignment. Only Python has, and it is a beautiful concept. So Python allows multiple assignments in a single line. So I can write a comma b is equal to 10 comma 20. What will happen? 10 and 20 will be stored in memory somewhere. Let's say 10 is stored here, 20 is stored here. And now I'm saying a comma b is equal to 10 comma 20. So a will get the value 10 and b will get the value 20. So essentially a is a variable name that will point to this memory location, and b is a variable name that will point to this memory location. And similarly I can write x equal to y equal to z equal to 5. So here what will happen? 5 will be stored in memory. 5 will be stored in memory, and three variable names x, y and z, all three of them will point to the same memory location. When I say x equal to y equal to z equal to 5, what will happen? 5 will be stored in memory, and all these three variables will point to the same memory location. Python always tries to optimize your storage. So what will happen, if you have x, y, z and you write x equal to y equal to z, then all these three variable names will be pointing to the same memory location. It is not that you will copy 5 3 times. So to save space, what it will do, when you write x equal to y, they both will point to the same memory location. Okay. And whenever you initialize the variable at that particular point in time, some memory block will be created. Let me give you an example. So let us say you have a Python program. Okay, and here you write x equal to y. First line is x equal to y. It doesn't make sense because y as a variable is not present right now. Right? There is no memory location you can point to. Right now you have not initialized any variable and you are saying x equal to y. So what will compiler say? Compiler will try to assign the, like whatever memory location y was pointing to, it will try to assign the same pointer to x. But right now y is not initialized, y is not created. There is no memory location y is pointing to. So this will give you an error. What you can do instead is, let us say you say y is equal to 3. When you say y is equal to 3, at that particular point in time in memory, some storage will be created, 3 will be stored there, and let us say the address of this particular memory location is 123. The address of this particular memory location is 123. Then now y will point to this memory location. Now a variable named y is created. So this is called variable initialization. This step is called variable initialization, right? And now if you say x equal to y, then compiler, what will compiler do? It will just create another variable name x and it will point to the same location y is pointing. It will not create another variable. X and y will point to the same memory location. So if you print x or print y, actually the same value 3 will be used. So it is saving space, right? It is not copying this to another memory location. When you write x equal to y, you are just saying that the pointer, like whatever address y was pointing to, x will also point to the same memory address. And similarly, like same thing happens here. When you say x equal to y equal to z equal to 5, a memory location will be created, value 5 will be stored, and let us say the address to this is 2000. Then now x, y, z, all three variables will be created and all three will point to the same memory location. Okay, so this is how variables are initialized and assigned in Python. You can actually create multiple variables in a single line by comma separated, and the first value will go here and the address to the second value will go to the second variable. Okay. And similarly, because of this reason, you can actually swap the values of two variables very easily. You can say a comma b is equal to b comma a. What does this line mean? Okay. So let us say a is having a value 10 and b is pointing to a value 20. And now I write a comma b is equal to b comma a. It means that whatever value b was pointing to initially, now a will point to that value. So initially b was pointing here and a was pointing here. So this line means whatever b was pointing to, now a will point to that, and whatever a was pointing to, b will point to that. So essentially their pointers will change. Now new pointers will look like this. So new pointers now will look like this. A will now point to this and b will now point to this. So new memory locations are not created. Actually the memory locations are same only. But now b is pointing to this memory location and a is pointing to this memory location. And these pointers will go away. So the same memory locations are used. Let us say this is address 1000 and this is address 2000. Then what will happen? Still like memory locations remain same. The address of the value 10 is same. Address of the value 20 is same. Only the thing that changed is now a is pointing to 2000 and b is pointing to 1000. So the pointers change, and hence we when we print the values, when I say print a and print b. So when I say print a, the value presented a is what? A is now pointing to this location, so the value printed will be 20. And the value presented b is what? It is 10. So we think that the values actually are swapped. Values are swapped, but actually the values in the memory locations are not swapped. Inside the memory, they are all right now they are present in the same memory locations. It's just that the variable names, they are now pointing to each other. Okay, so I hope this makes sense. And similar, like here we are achieving actually variable swapping. Okay, so it's not the values that is getting swapped. It is actually the pointer or the reference to the memory location which they were pointing to, that is getting swapped. Okay, so this is how variables are assigned and variables are swapped in Python. Now let's look at more such cases. So next concept is dynamic typing in Python. Very important concept. Generally in any other programming language, for example C, C++, or Java, whenever you are creating a variable, you have to tell the type of data while initializing the variable. In C programming language, if you have to create a variable of type integer, you have to say int a, like this. You have to tell the compiler that a is a variable which is pointing to an integer. Right? This is how it happens in C programming language, in C++ also, and in Java also. But in Python, you don't need to tell the type of the variable to the compiler. Python is dynamically typed. Same variable can point to any data type. So if I write a is equal to 3, automatically in memory 3 will be stored. We know that the data type of 3 is an integer, so integer type will be stored. Let us say it is at memory location 1000. So now a as a variable will point to this memory location. Okay, a is equal to 3 will do this. Now if I say a is equal to string hello, let us say, then at another memory location hello will be stored. Let us say this is memory location 2000. So what will happen? A will now start pointing to this. A will now start pointing to this memory location instead of this. This 3 will still be in memory. This 3 will still be in memory. This hello will also be in memory, but now A will be pointing to hello, not 3. So if you now print A, hello will be printed because A is pointing to this memory location. So same variable name can point to any data type. You don't need to tell the data type. You can just directly assign a different data type and it will understand. Because in another memory location, that particular value will be stored, and now that variable will be pointing to that memory location. Data type, writing the data type or telling the compiler the data type is not mandatory. You don't have to do it. The compiler will understand any data type and it can assign any variable to any data type. Okay. So you don't need to declare data types explicitly in Python. Variable types are determined at runtime. At runtime, you can have any variable pointing to any data type. So I can write x equal to 10, and then in the next line I can say x is now I am a string. So now x will become a string. Previously it was an int. Same variable. And at any point in time, if you want to check the data type, like what type of data a particular variable holds, we already know you can use the type function, and at that particular point in time you will just know that what type of data this particular variable is pointing to. Okay, so after this line, if I say type of x, it will give me str, but after this line, if I say type of x, it will give me int. Okay. Okay, now let us look at memory management. How is actually memory managed in Python for variables? Variables in Python are just labels, they are just names. Okay, and they can point to any memory location. They are not hardly typed, hardly connected to a memory location. Generally in other programming languages, what happens if you have a variable x at a memory location 1000, and let's say this is the memory location 1000 and some value is present, 35 is present, let's say, if you write x equal to 35. Now x will be hardly coupled to this particular memory location in other programming languages. But in Python it is not the case. In Python, a variable is just a name and it can actually point to any memory location. You can now change its memory location and point it to something else also. Okay. So that is how Python works. In Python, variables are just names and they are references to objects stored somewhere in memory. A variable name does not contain the value it points to. Variable name doesn't contain any information of the value. Variable name is just a pointer. It will point to a memory location. And when you print it or when you try to do some operations on it, then the compiler goes and sees what the value is. Okay, so when you try to print the value of x, at that particular point in time, the compiler will go and see what is present in the memory location 1000. 35 is present, so 35 will be printed. Okay, but as such, the variable name does not hold the value itself. The value is present at a memory location and the variable name is just pointing to that particular memory location. Okay, so here we have an example. Here we are seeing a is equal to 10. Again, like this, it's a similar example. I am saying a is equal to 10. So at a particular memory location, the value 10 will be stored. and let us say it is at memory location 3400. This is the address of the memory. Okay, in a computer, when you see computer architecture, you will know that every memory location has some address to it. So I'm just saying that, let's say at memory location 3400, the value 10 is stored, the value 10 is present. And when I say A is equal to 10, the variable A will point to this particular memory location. Okay, and when I say B is equal to a new variable will not be created. A new memory location will not be created. A is pointing to 3400. B will also start pointing to 3400. That's all. Okay, both the variables will point to the same memory location. So, like storage wise, right now in memory, only one time 10 is present. 10 is not present two times. 10 is present only one time at a single memory location. A and B are both pointing to the same memory location. So, when you print A and B both, same value will be printed, because A is also pointing to 10 and B is also pointing to the same location. 10 comma 10 will be printed. Okay, 10 space 10. Cool. Here A and B both are pointing to the same object, 10 in the memory. You don't have 10 present two times, 10 is present only once. Here we have another example, but this time we have an example of list. So let us see what is happening here. So here we have created, we are saying A is equal to the list 1, 2, 3. So in memory a list will be created 1, 2, 3 like this. Let us say this is present at memory location 2000. And we are saying A is pointing to this particular list. So the variable A is pointing to this list. Okay. And now we said B is equal to A. So when we say B is equal to A, B will also point to the same list. B will also point to the same list. And when I say B dot append 4, so right now you don't know what append function is. Don't worry about it. Like briefly, I'm just telling you what append function does. It will append this particular value to this list. We will see this in detail in the list lecture. But for now, just assume that when I say append, B dot append 4 means whatever list B is pointing to, in that particular list, you go and insert this element 4 at the end. So B is pointing to this list, and B dot append 4 means 4 will be appended to this list. So 4 will be added here. Observe that A is still pointing to the same list. B is also pointing to the same list. You actually appended 4 in B. You did not append 4 in A. But when you still print A, what will happen? A is also pointing to the same list only, right? New memory location was not created. So now when you print A, 1, 2, 3, 4 will be printed. The output will be 1, 2, 3, 4. Because variables in Python are just names. When you say B equal to A, actually the memory location A was pointing to, that was copied to B. So B and A are actually pointing to the same memory location. What if, like, see, you might ask, like, what just happened, right? We created two variables, A and B. Actually, just the value should be copied. But this is not how Python works. The value is not copied. They both point to the same memory location. If you want A and B to be different lists, then you cannot write this statement. If you want A and B to be pointing to different lists, you have to write here again, B is equal to list 1, 2, 3. Instead of this, if you write this statement, B is equal to the list 1, 2, 3, then actually what will happen? Another list will be created. After creating A, another list will be created with values 1, 2, 3. A is just containing 1, 2, 3, and let's say this is at memory location 4000. And B will be pointing to this list now. And when you say B dot append 4, 4 will be added here. And when you print A, now only 1, 2, 3 will be printed. But if you write B equal to A, then they will point to the same memory location. Okay, so if you want different lists, you have to create another list and assign that to B. So here A and B both are pointing to the same list object, and changing B also changes A. Okay, both will be changed. Now there is a very important function in Python called the ID function. ID function. You can check the memory address of any variable using the ID function. I told you every memory has an address, and for any variable, if you want to check what particular memory address it is pointing to, you can use the ID function in Python. So Python provides the built-in ID function to get the unique memory address for any object. So if I say x equal to 100 and y equal to 100, this is a beautiful example in Python, okay? Like I'll tell you what happens. It's a beautiful example. So what happens when you say x equal to 100? So 100 will be stored in memory. Let us say it is present in memory location. Let's not take 1000. Let's take 347. At memory location 347, the address is 347. The value present is 100. And when I say x equal to 100, x will now point to this memory location 347. Cool. Now when we say this was like this happened when you ran the line x equal to 100. Now the next line is y is equal to 100. Now in the last slide I told you that if you write y equal to 100, another memory location should be created, because in list that happened, right? When I said x equal to the list 1 2 3 and y equal to list 1 2 3, here another list is getting created for y. So x and y are pointing to different lists. But when x is equal to 100 and y equal to 100, this is a different example. Here something magical happens in Python. When you say x equal to 100 and y equal to 100, 100 is actually stored in a single memory location in Python. 100 will, you can never create multiple copies of values between, you can never create multiple copies of values between -5 and 256. Between -5 and 256 in Python. So let us try to explain, like understand this slowly. When you say x equal to 100 and y equal to 100, x and y will be always pointing to the same memory location. And this is true only for the values between -5 and 256, right? What is magical about these two numbers? Like between all the values between -5 and 256, only these have this property. Okay, these are called small integers in Python. These are called small integers. And only for small integers, a beautiful property happens in Python, and the property is you cannot create multiple copies of these numbers. For any string, you can create multiple copies. For any list, you can create multiple copies. For any complex number, floating point number, you can create multiple copies. So if you create a floating point number like this, x is equal to 100.0 and y is equal to 100.0. They both will be pointing to different memory locations. 100.0 will be stored and x will be pointing to this, and 100.0 will be stored and y will be pointing to this. For floating point numbers, this is not correct. Only for integers between -5 and 256. If it is of data type int and the values between -5 and 256, these are called small integers. And for these small integers, Python always tries to save memory, and only a single copy of these values can be present at a time. So when you say x equal to 100, 100 will be stored in memory, and when you say y equal to 100, compiler first checks कि 100 is present in memory or not. And actually these values or small integers are not present in memory, they are present in cache itself. Cache is the fastest form of memory and they can be accessed really quickly. Okay, so if you know computer architecture, you might know this. So these values or small integers are always stored in cache, and Python can quickly get them, and only a single copy of these values will be present in memory. So when you write x equal to 100, 100 will be stored in cache at 347. And when you write y equal to 100, since 100 is between -5 and 256, since 100 is between -5 and 256, another copy will not be created and y will also be pointing to the same memory location. It's beautiful, and it is an exception in Python, and it is true only for the values between -5 and 256. Okay, so x equal to 100, y equal to 100. If you print the address of x using id of x, and if you print the address of y using id of y, they will both point to the same memory location. Here we have just taken an example. When you run it, you might get some other address. Let us say that this particular memory location gets printed for x. For y also, same particular address will be printed, and this will be true only for the values between -5 and 256. Even if I give you an example, a beautiful example. Let us say I write x equal to 10 and I write y is equal to let's say 6 plus 4. Even here what will happen? X will have the value 10 and X will point to this memory location. And when you say Y is equal to 6 plus 4, this arithmetic operation actually evaluates to 10 only. And 10 is already present in cache. And since 10 is between -5 and 256, it is a small integer. Y will also point to the same memory location. So even after running these two lines, if you print the ID of X and Y, you will get the same ID. We will see in demo. We will try to do this and see in demo. Only for integers between -5 and 256, single copy gets created. For any other data type, for any other values, even values greater than 256 or smaller than -5. If you do -6, so actually what will happen? If you say X is equal to -6 and Y is equal to -6, since -6 is not between -5 and 256, right? -6 is smaller than -5. So it is not a small integer. Here two copies will be created. -6 will be stored in memory and another -6 will be stored in memory. X will point to this location and Y will point to this location. Okay, this is if you are initializing X and Y separately. Even here, if you write Y equal to X, then Y will point to the same location. If you write Y equal to X, then it will point to the same location. But if you write Y equal to -6, since -6 is not a small int, another copy will be created and Y will be pointing to this location. In this particular case, if you print the ID of X and Y, it will be different. Okay, I hope this is clear. So since like 100 is a small integer, the ID will be same. So notice X and Y have the same ID because the small integers in Python are interned. They are interned in Python. This property is called interning of a variable. Okay, interning means same memory location will be used and only small integers have this property between -5 and 256. Okay, so let us look at specifically at interning in Python now. So this is Python's object interning. Small integers which are -5 to 256 and some strings. So there are a few strings also which Python internally tries to intern. Like they will have the same memory address. They are not very commonly known. You don't need to remember all of those. Like for example, if you write hi, so like commonly used strings, like Python try to intern that because strings are also like they take up space. And if some strings are most commonly used, they like hold the same memory location in Python. So some strings and the integers from -5 to 256 are interned in Python. Basically, if you create this copy of them, you cannot do that. Like automatically the compiler will use the same copy for different variable names. Okay. Like small integers and some strings are cached or interned for performance in Python. Variables assigned to these values will point to the same memory object. So if you write x1 equal to 100 and y1 equal to 100, since 100 is between -5 and 256, it will be automatically interned. And the ID of x1 and y1 will be same. But if you write x2 equal to 500 and y2 equal to 500, now 500 is not between -5 and 256. So by default 500 will not be interned and different memory locations will be used for this 500 and this 500 and the ID of x2 and y2 will be different. So we'll try to run this in the demo and see like what the IDs are. But generally speaking, the IDs of these two will come different and x1 and y1 will come as same. And actually there is a way in which you can enforce interning for other values as well. For example, there is a particular value that my program uses like too many times. For example, let's say the value of pi. I'm working on a program for circles or something, and a floating point value of pi is something that will come up in calculations again and again in different variables. So you can enforce interning on certain values. There is a way to do that. Again, like that is some advanced level concepts of Python. Like you don't need to remember all those functions, but we will discuss that in the demo, like how you can enforce interning on other values that are not by default interned in Python. Cool. So next we have variable rebinding. So let's understand this concept. When you reassign a variable, it simply points to a new object. The old object stays in memory if other references exist. So what do we mean by this? Let us say we defined x is equal to 10 and we said y is equal to x, and then we said now x is equal to 20. Okay. So when I write x equal to 10 in memory, 10 will be stored. Let us say it is stored at memory location 123 and x is pointing to this memory location. And when I say y is equal to x, y will also point to the same memory location x is pointing to. And when we say x equal to 20 now, so 20 will be stored in memory now. Let's say it is at memory location 256. Now x will stop pointing at 123 and now x will start pointing at this particular memory location, right? So you actually rebinded the memory location x was referring to. This is called memory rebinding, right? Because initially x was referring to memory location 123, but when you change the value, x is now pointing to memory location 256. Now this particular memory location 123, which stores the value 10, what will happen to it? Now see, x is now pointing to this particular memory location, right? So what will happen to 123? Since y is still pointing to this particular memory location, this memory location will not be deleted. Okay. See, if you think about it, like think of it like this, like what actually happens inside when you actually ran this particular line, x is equal to 10. So 10 will be stored in memory. Let us say at memory location 123. So the compiler will also remember that at memory location 123, x is pointing to this particular memory location, and hence it will say that the variable count is the number of variables that are pointing to this particular memory location. That will become 1 because x is pointing to this memory location. Now when you say y is equal to x, y also starts pointing to this particular memory location. So the variable count of this particular memory location becomes 2 because now 2 variables are pointing to this memory location. Now when you say x is equal to 20, so 20 will be stored in the memory, let us say at location 456. Okay, and now x will start pointing to this memory location. So x will not be pointing to 123 anymore. So now what will happen? The compiler will know that at memory address 456, one pointer is pointing, which is x, and it will remove 1 from here because now at 123 only one pointer is pointing, not x, only y is pointing. So the count will go from 123 to 456. Now compiler knows that still one pointer points to 123 and one pointer points to 456. So it will not delete the values at any memory location on which at least one variable is pointing to. So the compiler will not delete what is present at 123 or 456 because still some variables are pointing to 123 and some variables are pointing to 456. Only if the count becomes 0. So let us say I again write one more statement, y is equal to 20. Now what will happen? Because since 20 is between 5 and 256, new memory location for 20 will not be created. 20 is actually cached or interned. So same memory location will be used and y will now also start pointing to the same memory location. So this count will now become 0 and this count will now become 2 because x and y are both pointing to the same memory location 456. Now what happens? For memory location 123, the count has become 0, which means now the compiler knows that at this particular memory location, no variables are pointing to it. So you now cannot guarantee that 10 will be stored in memory or not. At any point in time, like at certain point in time, like this memory location 123, because no one is pointing to it, at certain point in time, this memory location will be freed up. It might be overwritten. It might be overwritten some other values. Basically, this particular memory location is now free. It can be used by other variables or other values also. Okay. So essentially, this particular pointer or this particular memory location at which no pointers are pointing to or no variables are pointing to is called garbage. It is like garbage, right? No one is using it, but still it is taking up some memory. That value is taking up some memory. So this is like this memory location is called garbage. So we will see what happens to garbage in Python. But firstly, let's understand rebinding. So when you reassign a variable, it simply points to a new object. The old object stays if memory stays in memory if other references exist. So this happens through the count. Okay. So if you say x equal to 5 and you print the id of x, some memory address of 5 will be printed. And if you say x equal to 10 and if you print the ID of X now, another memory location will be printed, not the same. So 10 will not be stored at the same memory location, it will be stored at some other memory location, and now X points to that. Now this particular memory location where 5 was present is right now garbage because no one else is pointing to it. Okay. So like before going to like what happens to garbage, here is an exercise for you. Try to solve it on your own. Like what will happen in like what will come in these 3 outputs. We will try to solve it in the demo. Okay, you can pause the video and try to think about it. Like what happens in this exercise. We will discuss it at the end in the demo. Cool. So now let's look at garbage collection. I told you, like if no pointer or no variable is pointing to a memory location, that memory location contains garbage because no one is using it. But there is a value present at a memory location and no variable is pointing to it. That particular memory location or that value is called garbage, and Python periodically or automatically cleans up the garbage. Okay, it will free up all these memory locations periodically. Once in a while, it will try to collect all the garbage present. So Python automatically handles memory cleanup. You don't need to do it. When no variable references an object anymore, it becomes eligible for garbage collection. It becomes eligible for garbage collection because that is garbage. Now reference counting, it is the same concept that I told you. Reference counting is just counting at every memory location how many variables are pointing to. Reference counting is the primary technique. When an object's reference count drops to 0, it is deleted or garbage is getting collected. So like Python automatically will take care of garbage collection. Generally you don't need to do it. Once in a while when there is less memory available, Python will try to collect the garbage so that more memory is now available for other variables. But if you want to again enforce garbage collection, if you are thinking that you are not getting enough memory and at certain point in time you are writing a large program and you feel that at this particular point in time, from this point I need a lot of variables at once and my program might crash because if the garbage is not collected from before, the program might crash and memory will not be available. You can enforce garbage collection through program as well. There is a library called GC which means garbage collector. So you can import GC and then you can just run the command gc.collect. If you run gc.collect command, automatically garbage collector will invoke and at that particular point in time, a garbage collection will happen. Okay, this will force garbage collection. Cool. Now let us look at deleting variables. So what if there is a variable or a memory space that you don't want to use anymore? Let's say you had a is equal to 10 and 10 was stored and a was pointing to it. But you don't want this particular variable anymore in the program. Why waste it? Why waste this particular memory space? So there is a delete command in Python. You can write delete a. Okay, so delete command actually essentially frees up the space and it deletes the variable name completely. Even the variable name won't exist anymore. The variable name and the value present in it, everything will be freed up. Even the memory location will be freed up and the variable itself cannot be used anymore. So when you use delete keyword in Python, it is a keyword, okay? Among the 35 keywords that we saw in the lecture, delete is one of the keywords, del, okay? To delete variables in Python, and you don't need to import any library for it. Python compiler understands this keyword. Let's say a is equal to 100 and if you delete a, now after this you cannot use a anymore. You cannot say now b is equal to a. This will give you an error. Because after this line, the variable named a does not exist anymore. So it will give you an error. So if you access a now after this line, it will raise a name error because this particular name a does not exist anymore. It is deleted forever. So by deleting forever, it doesn't mean that you cannot create it again. You can again create it. You can say that a is equal to 10 and then delete a. Then you can again say a is equal to 5. After deleting, you can create it again. But before creating, you cannot use it. You cannot say c is equal to a plus 2 because a doesn't exist. You need to create it again. Okay. So this is how deleting of variables work in Python. So while creating variables, there are some good practices which you can follow and that will make your program look good. And these are the general practices which everyone follows while naming variables. Again, like the rules for naming variables, we already know. The variable name is an identifier. So all the rules related to identifier, we already know. It can only contain characters or digits or underscore. It cannot start with a digit. Generally, we don't start variable names with underscore because they have some meaning, or double underscores. So we know this all. But these are some of the best practices you can follow while naming variables in Python. First, use meaningful names like score, temperature instead of x, val, because you know it right now what x, y or val means. But someone else who is looking at the program will not know, and they will not be able to understand what this particular variable does or what this particular variable stores. So generally you should name variables in a meaningful way so that if someone else is reading your program, they can understand easily. Or even if you are looking at after, let's say 1 year, you should be able to understand, right? So this is called a human readable code. So your code should be highly readable and try to use meaningful names. Again, the next general practice that is followed is, for variable names, you can use lowercase letters and underscores for multi-word names. So let us say you want to name, create a variable called roll number. So the general practice is, for variables, we use underscores like this. You can name the variable like this. And this is called snake case style. Okay, snake case, which has underscores. Okay, so generally variables are created using lowercase characters. If you start if you start a variable name with a capital letter, they are generally done for classes. For variables, people follow this practice that they should name it in small case characters. Again, if you want, you can name variable anything. You can name a variable like this, hello. But this is not a general practice that we follow. This is generally used for classes. There is no rule, but this is a guideline that generally people follow, so that by seeing the variable itself, they will know it is a variable name, not a class name. Okay. Also, if you want to declare some constant values, again, it is not a rule. If you want to declare constant values, that will not change in the program generally. Let us say I want to create a variable called pi 3.141. So the value of pi will not change. You just want to use the value of pi again and again in program. So instead of naming it like this is also fine. But generally for constants, people use capital letters, so that again, if someone else is reading your program, they will know that generally, like if you are using all capital letters, then you are actually naming a constant that will probably not change in the program later. So use uppercase variable names for constants. Next is avoid overwriting built-in names like list, sum. So see, sum has a specific meaning, right? Sum means summing up, although sum is not a keyword. But some function is present in NumPy, we will see it later. Sum has a meaning, right? So don't use these kind of names. Like if they are not signifying that particular property. Like although the variable was doing something else, but I am naming it sum. So that will create confusion. So have meaningful names and have a name such that it follows the property of what it is trying to do. Next is know when references are shared, especially for mutable objects. See, again, I gave you an example, right? If the reference is shared, so if you create a list like this, if you say A is equal to the list 1, 2, 3, and list is a mutable object. Tuple is not a mutable object. For tuple, there is not a problem, because in tuple you cannot change values, but in list you can change values. And if you say B is equal to A, now they both are sharing the same reference. So now if you change B, A will also change. If you change A, B will also change. So be mindful. If you want another copy, create another list. Don't assign the variable value itself. This will actually assign the address, and hence both will be pointing to the same memory location. Be mindful of this, especially in case of mutable objects, because in that case one value can change and the other variable will also be changed because of that. So if the reference is shared between multiple variables, be mindful, and especially in case of mutable objects. Next, if you plan to assign a value later, if you just want to create a placeholder for now, I want to create a variable called name, but I don't have a value for it right now. I will ask the user what the value of name is, and then later at some other point in time in the program, I want to use this variable. So you don't have any particular data type or value right now in mind, but you want to reserve this particular variable name. Then you can use none for that. We know that none is a keyword, and none is actually a constant literal, right? So you can use none for these cases. You can say that name is equal to none. It is essentially like saying that right now this particular variable contains nothing, but this variable I will try to use some at some other point in program. Okay, but right now I just wanted to reserve this variable name. I might use it at some other point in time in the same program, but right now I don't know what the value should be or what data type it should have. Then you can just assign none to it. Okay, these are some of the best practices to follow while you are using variables in Python. Now I told you one thing. After we discuss data types and variables, we actually, like when we were discussing operators in Python, we covered arithmetic, assignment, comparison, logical and bitwise operators. But we did not cover two operators, which are membership operators and identity operators. The reason is, like, you will be able to understand them better after, like, since we have already covered data types and variables both. Now, now is the right time to cover the membership operators and identity operators as well. So in this lecture only, let's see what the membership operators in Python are and what the identity operators in Python are. Okay. So first is membership operators. We have already seen many operators in Python in the operator lecture. But there are some special type of operators in Python as well. First is membership operator. They just check that a particular element is present in a collection or not. We already know what collection is, what list, tuple, dictionary, all of these are collections. Okay. And if you want to check a particular element is present in a tuple or not, in a set or not, or in a list or not, you can use the membership operator. And the operator is in and not in. Not in is just the opposite of in. So in will return true if the value is present in the collection, and it will return false if the value is not present in the collection. And similarly, not in is what? Not in will return true if the value is not present in the collection, and it will return false if the value is present in the collection. So they are used to test membership in sequences or collections. So let us say you created a list called fruits, and it contains the values apple and banana. So you can just ask, like, is apple in fruits? So we are just checking that the string apple, is present in the list fruits or not. Since this particular string apple is present in this list, this will give you true. But again, like, see, every string is different, like, and Python is case sensitive language. So if you ask, is this apple is present in fruits? This particular string is not present. Python is case sensitive language. This string is different from this string because A is capital here. So this will give you false. Okay. Now similarly, is grape not in fruits? Grape is not in fruits, right? This particular string is not in fruits. So this will also give you true. Okay. So this is how the membership operator works. Again, when we discuss all the data types in detail later, like in tuples, dictionaries, how is this used, we will see in detail later. But right now you got an idea, right? How the membership operator works. It will just check that a particular value is present in that collection or not. Similarly, next one is identity operator. Identity operators are used to check if two variables refer to the same object or not. Okay, like in and not in, here we have is and is not. Be mindful. The membership operators were in and not in, right? But identity operators are is and is not. Simple English. Okay. So what does is operator do? You can ask questions like this. A is B. A is B. Let us say there are two variables A and B, and you have asked A is B. You want to print the value of A is B. Again, it will also give you the output as true or false. Membership operator, identity operator, comparison operator, all of them give you only Boolean output, true or false. So this will also give you true or false as output. This will essentially check that A and B are pointing to the same memory location or not. Okay, it will essentially check they are pointing to the same memory location or not. So if ID of A is equal to the ID of B, if ID of A and ID of B are same, essentially if they are pointing to the same memory location, then this will give you true. Otherwise it will give you false. So it will just check like is the ID of two variables same or not. See, you will not be able to understand it before we did this lecture, right? Because in this lecture we understood what ID means or what the address of a variable means. So this is what the identity operator does. It just check key two variables are pointing to the same memory location or not. And similarly, is not is opposite of is. So if you ask A is not B, so it will return true if ID of A and B are different. If ID of both of them are different, if they are pointing to different locations, then it will return true, and it will return false if the ID is same. Okay. So this is how the identity operator works. Is returns true if both refer to the same object. Is not returns true if they refer to different objects. Here is an example. A is pointing to a list containing 1, 2 and B is pointing to the same list, and C is pointing to another list. Like, so let's try to draw it. What will happen if you run this piece of program? When you run A is equal to list containing 1, 2, a list containing 1, 2 will be created in memory. Let us say it is present in memory location 100. Okay, and A will be pointing to this. Now when you say B is equal to A, B equal to A means address of A will be copied to B. So B will also point to the same list. And when you say C is equal to list 1, 2, so by default lists are not interned. Only integers between -5 and 256 are interned. So this will not be interned. Another list will be created containing 1, 2, and let's say it is at memory location 200 and C is pointing to this particular memory location. So if you ask the compiler, A is B, A and B are pointing to the same memory location, and hence A is B will give you true. And if you ask A is C, A and C are not same, so it will give you false. Okay, this is how the identity operator in Python works. So these were like all the operators in Python, and we have discussed like how the variables are variables in Python work, how the memory management in Python works, how garbage collector works. Now let us see a demo on variables in Python.
Okay, now let's see a demo on variables and memory management. So firstly, let's start by creating some variables and see their type. So let's say I said name is Alice, age is 25, and let's say is a student was good, is true, and let's say marks is a dictionary. So in dictionary we will write two things, maths, let's say we have 34, and science, let's say 46. Okay, and now we will print the print everything, and we will print the type. So like this is like very simple way of creating a variable and assigning a value to it. So we can assign any type of value to any variable. Just the name of the variable is an identifier. It should follow all the rules of an identifier. So if I just write f in the formatted string name, let's say name is name, and type of name is type of name, and yeah, this is good, and at the end marks. So I'm printing the name, age, is student, and marks, and I'm printing the type of each one of them. Okay, so okay, there is some cool. So the name is Alice and the type is a string. We have a string, and then the age is of type integer, and is the student is true of type bool, and marks is of type dict. So we can create variables of different types and then store them, and then we can see their type using the type function. So simple so far. Okay, now we can actually do multiple assignment in Python as well, which means we can store the values of two variables at once. Let's say 10, 20. And then we can print the value of A and value of B, and like both of them are assigned in a single line. 10 is assigned to A and 20 is assigned to B. How this internally works is through tuple packing and unpacking, that we will see in tuples lecture in detail how this statement exactly works. Okay, and we can assign multiple variables the same value as well, like this: x is equal to y is equal to z is equal to 10. So here x, y and z, all three are 10 and they are all assigned the same value in a single line. Okay, and we can swap values as well. So here the value of a and b were 10 and 20. So we can swap the values of a and b using multiple assignment. This is something that we have seen in class. So I can write a comma b is equal to b comma a, and then if I again print the value of a and value of b, they will be 20 and 10. They will be swapped. So using multiple assignment, we can swap the values of two variables as well. Now let us move to dynamic typing. So in Python, any variable is not hardly tied to a data type. This is different from C and C++ and Java. There one variable will be of one data type only. Here one variable can take multiple data type, multiple values of different data types in the same program. So if I say x is equal to 10, and if I print value of x and type of x, and then if I say x is now, let's say I am a string. Okay, so firstly it is an integer, now it is a string. So the same variable x can firstly be an integer and then a string. This is allowed. And now when you print x and type, firstly it was an integer and then now it is a string. Okay, so this is all about creating variables and assigning variables. Now let us move to memory management, okay, which is very interesting concept. So how is memory handled? We have seen that in detail in the lecture. So let us create a variable and assign the value 10. And if I say b is now another variable which is having the same value as a, then a and b will have the same value, right? So if I say print a and b, the values of a and b will be same. And we can use the is operator as well. We have seen the is operator now. So if I write a is b, they will be having the same memory address. Okay, they will be having the same memory address, which was expected. I have just written a is b. I have not printed it here, but like I'm using the feature that the last line of the cell will be displayed anyway. So yep, like they will have the same memory address. If you want it to be clean, you can add a print here as well. We are just printing a is b or not. Now we can see the same code, like when you create a variable and you assign any sequence to it, and if you say b is equal to a, and now let's say if I say b dot append 4, they will actually, whenever you write assignment like this, address is copied, not the value. So they will be they will be pointing to the same memory location. Whenever you're writing b is equal to a, they will be pointing to the same memory location. So b is equal to a, what will happen? B dot append 4, and even if you print a, the same list 1 2 3 4 will be printed. Even though you appended 4 to b, it will be appended to a as well, because it is essentially the same memory location, and a and b both variables are pointing to the same memory location. You can verify it as well. You can print a is b and you will get true, because they are pointing to the same memory location. Okay, now let us look at the concept of memory interning. Actually here in both these examples, let's try to see the memory locations as well, just to be sure. ID of a and ID of b. So here the same memory address is getting printed, and even here it is a list. Here also if I print ID of a and ID of b, here also if not if is I want to print. Okay, so here also I will get the same memory location. So these are multiple ways of verifying the same thing. Coming to object interning, what happens is small integers. Okay, let's say I take a variable and I give it a value 100. So all the variables before 256, they will be interned, which means only a single copy of them will be present in memory, no matter how many times you assign it to different variables. So if you print x is y and the ID of x and y, they will be same. X is y, correct, because small integers are interned in Python and hence their ID is same. You can see the same ID. Even though you were assigning it, like you are not saying y is equal to x. Instead, because it is a small integer, 100, between -5 and 256, yes, it will be interned and hence the ID will be same. Now a bigger example for the same, let's say x1 is equal to let's say like another example, let's say x1 is equal to 257. Yes, 257 is not a small integer, it is a big integer, and hence now if you assign 257 to x1 and 257 to y1, their ID will not be same. It is like only integers less than 256, they will be interned. Okay, so this is about object interning. Now let us look at variable rebinding. Variable rebinding means we can actually when I assign different values to the same variable, the memory location changes. The memory location changes because in Python, the memory address is not associated with a variable. It is associated with a value. A value is present at a memory location, it will stay there. If you are assigning a different value to a variable, it will be stored somewhere else, and then now this variable will be pointing there. We have seen this concept, and the previous memory location will be now garbage. So to verify this, if I say x is equal to 5, and if I print the ID of x, which means the address of x, and if I now say x is equal to 10, and now if I print the ID of x, the IDs will be different because they are interned. Even if they are not interned, let's say if I say 500 and 1000, still now the addresses will be different because they will be stored in different memory locations. And now let's say if I say x is equal to a string hello, and now if I print ID of x, again now a different ID will be returned. Now here in this case, these two are garbages. Now let us look at, like, since we have left a lot of garbage because no variables are pointing towards them, how do we collect garbage? We have seen this. We just have to import the garbage collector. Actually it happens automatically once in a while, but if you want to enforce garbage collection, if you are thinking that you are running out of memory, you can enforce garbage collection as well. For that you just need to import gc, which is garbage collector in Python, and then you just need to say gc.collect. This will just collect all the garbage at this moment, and it will return how many memory location it accessed and so on. Okay, so all the garbage is collected. And if you want to make sure that you are not throwing away any garbage, you are not creating any garbage, you can use the del keyword to delete any variable. So let's say if I create a variable with a value 100, and if I delete it, del a, then now a does not exist. After deleting this variable and the memory location, it does not exist. So now if I, after this, if I print the value of a, it will say a is not defined. Okay, because you have actually deleted it, and hence now you cannot access it anymore. So this is all that we saw in class, like the concept of interning, ID is how it works, and dynamic typing and so on. So this was all about variables and memory management in Python. Thanks a lot. See you in the next lecture. Bye bye.